Hello, hello, everyone. Welcome to the React Meetup online. I'm super excited for today's meetup. We have two awesome speakers, and always thanks so much to this.labs for sponsoring and making this event happen. Just as an FYI, this dot is a consultancy, and we work with different technologies like React, Angular, Vue.js, and other JavaScript technologies. So if you ever need help in one of your projects, hit us up. A few announcements. The Vue Online meetup is going to happen on March 12th, which is tomorrow, if I'm not mistaken. And no, it's actually today. It happened already. And then the Angular meetup is going to happen on April the 2nd. Right, and the React meetup, the next one is going to be on April 9th. So just be aware of that and make sure you mark it down in your calendar. We have more awesome speakers. And today we have Rob. He's actually my coworker. He's a team lead and a software architect at this.labs. He's an awesome person to work with. I really enjoy working with him. And another guest that we have is Rishi. He's an engineer for Hasura. So today we're going to hear about them, about their topic. And the first speaker is going to be Rob. So I'm going to give the access to Rob to start presenting. Rob, are you ready?
Yeah, all set.
Perfect. Okay, give me a second. So.
Okay. Hello, everybody. Thank you so much for being here. Thank you for the opportunity to speak. Today, we're going to be talking about component decomposition, things that I call pitfalls, and some strategies and ways to avoid them. So as Pato mentioned, hang on. Of course, things go haywire when they go live. Okay, there we go. For some reason, got stuck on the first slide. There we go. As Pato was mentioning, my name is Rob Ocel. I'm a software architect at this.labs. I'm also a host of a couple of our podcasts, like the Modern Web podcast and the this.labs podcast. I'm a speaker on things like the PAM stack, which I don't have time to get into now, but I love talking about it. So if you're curious, hit me up on Twitter and we can discuss what that is. Front-end frameworks, mentorship, and all things related similar to that. You can find me online on Twitter at RobOcel. It's my name spelled slightly wrong. So as we get started, I just want you guys to think, like, how many times have you went to fix a bug in a modern framework single page application, and maybe you opened up a component file and you were trying to find where something went wrong, and you realized that that file was, say, hundreds or maybe even thousands of lines long? Or how many times have you had this experience of unwrapping like layer after layer of components, and every time you open one up, it just has a single tag and no code inside of it until your IDE is just completely full of tabs and open files, and you still can't find the thing that you're looking for? Or maybe you've been like me, where you've tried to figure out how a particular value keeps changing, even though you think you know where it's edited, and you've put all the statements that you can trying to find what's going on, and none of them seem to be hit, but somehow that value is still changing. If you've encountered any of these issues or just general problems navigating or debugging your front-end component-based application, it's okay. A lot of us have these problems, and the good thing is that we can actually fix this and we can make improvements. So to start out, what is decomposition, or what do I mean by it, or how are we going to be describing it? So to do this, I love to post this in sort of the opposite way, which is to say, realize that in all of our single page applications that we might be building with React, we could actually build them, the entire thing, as one component, one monolithic, massive component that's thousands and thousands of lines long. It has the most complicated template that you've ever seen, with all sorts of conditionals where things are hidden and not hidden. Now, please don't do this. That would be absolutely impossible to work with. But realize that that is what we could do. So what do we want to do instead? Well, of course, we want to break that gigantic component into smaller, useful pieces. Well, what's the way that we're going to do this? Well, we could break it up in sort of haphazard ways, just sort of taking random conglomerations of 50 and 100 lines and moving them into arbitrary files. or we can break it up in a more intentional way. And that's what we're going to be calling component decomposition, and that's what we're going to be looking at. The process of breaking up a really large application into smaller and smaller nested components, with the ideal state that we're breaking these up in intentional ways to meet other architectural goals, such as understandability or maintainability, modularity, or any of the other ilities that might be important to you and your team. Now, why is this process so hard? Well, first of all, this process is hard because there's no one right way to do this. It's not like I can tell you the equation and you punch in the information from your application and out spits exactly how you should break up your application into components. This is much more of a feel thing. This is much more a trade-offs thing. This is much more a what works best for your team or your particular use case. The second reason this is so hard is because as developers, we're often prone to premature optimization. We love to look for patterns. We like to try and earn our paychecks. We like to try and get ahead of what we feel is like going to be the things that we have to fix in the future. So oftentimes we'll try to make things more generic than they might actually be. And also, I like to point to object-oriented instincts. Now, a lot of us have been programmed to think in object-oriented terms. A lot of development programs still teach in this way, and a lot of us, that's how we learned. And when you think in that paradigm, you often think with the idea of inheritance. You're always looking for the ways that things are very, very similar or can be the same, but differ in very subtle ways. People that come from more of a functional programming background start to think not so much about how the ways that things can be the same, but rather how you can compose small things together to make more complicated wholes, right? So people that come with that object-oriented instinct, sometimes some of this does not come naturally to them. So let's dig into a couple of the problems. Now, sometimes I've called this the Goldilocks problem of decomposition, where some people do too much and some people do too little. And we'll kind of look at what some of the effects are of both of those. So the first is when you have too much decomposition, meaning you have way too many components in your application. Now, the best example of this that I can think of is actually this example from the React documentation. Now, let me stop and say that I love the React documentation, and I think the React team does an excellent job in their documentation. But this image has tripped up so many teams that I've been on before. What this image is showing is what they call the way to think in React. And here we have kind of like a visual design given from a designer. And the colored boxes around sections of this are meant to represent where we'll break up our components. And you can kind of see the boxes sort of nest inside each other. And when people misunderstand this image, they think that what they're supposed to be doing in their applications is taking a visual design and then drawing a box around the whole thing, and then drawing slightly smaller boxes, only excluding like one or two things until every single thing is in all these deeply nested recursive boxes. This sort of nesting doll component approach can really cause a problem because a lot of times when people do that naively, a lot of those components don't have a strong purpose. And so people get really confused and then they start to drown in all those files. And pretty soon it's just so difficult for them to navigate around. Or people cut boundaries between components that seem like they should exist, but they don't really work well. So I'm guilty of this more than anybody. Anytime I know I'm about to make a list of something, I immediately run out. I make my list component, I make my list item component, and then I'm like, I'll get back to them later. And when I come back to them, I'm like, okay, great. My list component is a UL, and my list item component is an LI, and I did it. I made my two components, right? But each of these components isn't terribly useful. I always have to use them in concert with one another. They're very dependent on one another. They're not very complex. And there's really no reason that these things have to be separate. Now, another example comes when people have like a large page or a large feature that they're working on, and they know that they're supposed to have small components, so they kind of make cuts in weird places. So imagine we're trying to implement this form, and this form has 3 sections. And you know that this is too long and you want to make it smaller. And so your first idea on how to make it smaller is simply to say, well, I know I have a form and then I have 3 sections. So I'll just make a personal information component, an account information component, and a contact information component. Many of you, including myself, have probably done this before as a way to try and reduce size. But the problem here is that each of these components is actually meant to be used exactly in the way that it's being used here, meaning that they have all sorts of hidden dependencies on each other, and they actually relate to each other a lot more strongly than you'd think. So what happens? Whenever you're working on this page, you tend to have 4 files open all the time. You have each of these components open because you often make changes to many of them at the same time. This isn't actually saving us time, it's not saving us attention, and it's not actually making things any easier. We feel like it is, but it isn't. So the other side of this problem is what happens if you have too little decomposition or too few isolated components. Well, this leads to something that I like to call the Bob Ross problem. So the Bob Ross problem comes when developers get visual specs from designers, and instead of reusing or looking for opportunities to reuse, they immediately start painting every single new page with fresh CSS and fresh HTML as if nothing else in the system already existed. This means that you don't have the ability to replicate changes across the entire application, right? This works okay, but when a designer comes back and says, I want to change the size of all our headers or our fonts, you start to go and look for all the places where you are using those headers or those fonts, and maybe you find out that somebody had not quite used the same font, but used a font that was very similar or a size that was very similar, so your find replace didn't find it, and you end up with all these regressions in different places in your app. Another interesting case are when people need to build very similar components like material design cards, right? So these are different cards for material design, and you can tell that they're very similar, but they're also very different from one another. And it might not be obvious to people at first how to actually share code between them. You might think that you just want one component and parameterize it, or you might think, well, I don't know how to do this, but I should make 3 completely different components, and I'll just copy paste a lot of code between them. This leads to a problem that I like to call the one component trapped in another problem. And it might seem like this this duplication is actually due to too much decomposition, right? We're making too many different components. We should just combine these together to one card with all these parameters. But it's actually more due to the fact that we haven't done enough decomposition of the pieces that build these cards. So how is this actually solved? In material design libraries like Material UI, they solve this by having smaller composable components like card title, card image, card description, card actions, and so on, which are then used to build up these larger card prototypes that are varied in different ways. Now, sometimes people try to be too clever and reduce the number of components, as I just said, by forcing reuse when there isn't reuse. This can happen when 2 components are very similar but slightly different, and people aren't sure if they're meant to be the same or they're just incidentally, like accidentally similar. When I went to go find an example of this, I actually watched this talk, React is Fiction, by Jen Creighton, which was at last year's React Conf, and she had absolutely the most perfect example, and I have not been able to get it out of my head since. So I'm going to borrow her example here. But what I would ask is, after this talk, after both of these talks today, that you go watch this conference talk because it is absolutely fabulous. Then reach out to Jen on Twitter and say that you watched it and that you appreciated it. So what is she trying to do in her example? She's trying to build a header, and this header, which many of us have in our applications, is going to differ whether the user is logged in or not logged in. If the user's not logged in, they're going to see some additional sign-up links, and if they are logged in, they're going to see like a profile and maybe some additional links in the top bar that are only for users. So how might you implement this? Well, a first obvious way that someone might choose to implement this is to do this, to have a navigation component that takes an isLoggedIn Boolean. And that isLoggedIn Boolean prop is going to determine whether you show the login and sign-up links or the avatar links. Now, what's wrong here? Well, nothing is actually wrong here as long as nothing really changes. These things are very similar to one another, and this is maybe the fewest amount of lines we can write and actually implement both components in one component. But what happens if these designs start to deviate from one another? What if we decide to have a new feature where we want to show different content whether the logged in user is an admin or just a normal user? Well, suddenly now the amount of props that you have on this component is growing. And you start having these combined Booleans, right? Is logged in but not user sees this, is logged in but not admin sees this other piece. And the odds that you go in and try to make a change that affects only one of the use cases, but accidentally cause a regression in one of the other use cases grows quite large. And so we can see that this well-intentioned combination can actually be a problem where we just need more components, and we should actually split these things up into 2 distinct components, which we'll talk about later. So if those are a lot of the ways that things go wrong, and if you've looked at this and say, well, we do that in my app right now, and yeah, that has been really difficult to work with, it's okay. I have some ideas on things that I've learned on some of the teams, hard-fought lessons that I've learned on teams that I've worked on that I think help to crystallize conversations around when we should actually split things up into new components and when we shouldn't. So the first and the most obvious of these is that components are good when they're routable. So you should put content which is going to be swapped in and out of the view together into a single component. Now, the interesting thing about this is, and the reason why it's maybe obvious to a lot of people, is that this is actually how a lot of the routers work in these single-page applications, right? You define a certain route, and then you say a certain component that you want to host at that route. So the content that comes in and out with that route is combined together into a single component. Now, this, again, might seem like an obvious strategy, but still a lot of people don't do this in other cases which are not related to the route. So things like wizards or tabs or similar things. Now, not always do you have to make this these routable things components, but it's often a good thing if those things which are going to be routed are also independent. So an example of that could be this wizard. So here we have a 3-step wizard where each of the steps is going to be independent from each of the other steps. So we could say that we're going to have a component which controls this overall wizard, and then components which represent the forms on each of the 3 steps. Now, this works really well because each of those steps, again, is independent. What you do with your personal information is different than the bank account step, is different than the financial goal step. And it's that independence that lets us split these off into other components which are smaller and less complicated and more focused on a particular task than they would otherwise be if we combined them all together. The reason why this is different than the form example from earlier is because in the form example, we were talking about very related pieces of information. And in here, those pieces aren't related, right? So again, this is the most obvious strategy and the one that I think most people are probably using now. The next is reusable components. So when we're talking about reusable components, you might be saying, well, obviously I know I want to put things that are reusable into components, but the hard part is figuring out where that reuse is. Sure, but it's still worth saying that this is what we want to try to do. The goal is to try and create small components that can be used when combined together to build more complex components more easily. Our goal while doing this is to try and avoid making multimodal or overly similar components. And the reason for that is because when you have more focused components, more simple components, less quote unquote intelligent components, components which are less aware of the overall context of your application, they're going to be more easily reusable, right? The more complex, the more structured, the more varied that those things are, the more specialized components are, the more difficult it is to reuse. Design systems, of course, are a great source of reusable components, and that's going to be our example. So remember, we're talking about this form from earlier that we had previously thought about splitting into 3 sections, which we thought were distinct and smaller, but actually weren't. So how can we make this page a little bit easier to construct? Well, we could do it perhaps by separating all the things which we redo over and over and over again on this page and bring those into components themselves. So things like cards or typography or input components. Does that mean that every one of your apps needs these things? No, but you can realize maybe your inputs are always styled a certain way, or they have particular animations or particular validations that are unique to your application, or whatever it is. Whenever you find yourself repeating something over and over and over again, you can combine that together into these reusable components. But what we're enforcing this reusability at the smallest possible level where things are proven to be reusable. And if we ever find ourselves reiterating these patterns over and over again, we could then combine some of these smaller elements into medium-sized elements, and so on and so forth onto larger and larger elements, as long as they prove themselves to be reusable. The next strategy is to use and prefer specific components. So specific components is this idea that we want to force our abstractions to prove themselves. One thing that you might have heard is to follow the rule of 3. So the rule of 3 says to at least hold off on making abstractions until you've seen at least 3 of something. So some people, as soon as they see something that looks like something they've done before, they're like, oh, I can't have 2 things that are similar. I must find something that is common and abstract between them. This rule says, hold off. Wait until you've seen more instances of reuse, because that's going to help you know what is actually common amongst these use cases versus what is actually unique. And waiting can be invaluable in terms of saving you time, not having to unwind a bad abstraction. So Sandy Metz put it as prefer duplication over the wrong abstraction. And if there's one thing you get from this talk, I'd say it's that. In 2020, please rely on copy-paste more than you think you might want to, right? Prefer duplication and repeating yourself over prematurely abstracting the wrong abstraction. Ken C. Dodds likes to call this aha programming, or avoiding hasty abstractions, versus dry programming, or don't repeat yourself. That's the one that we've probably all heard, right? It's probably the most repeated phrase in software development, don't repeat yourself. And I'm saying that when you're doing UI development, when you're doing component development, I think those instincts work against us more than they work for us, at least in the realm of UI development, right? I'm not saying that dry is a bad idea. it's definitely a great idea, but that we might want to resist it a little bit when we're working in our UI. So to understand this a little bit more smoothly, let's talk about Jen Creighton's talk. And remember that we're building these headers. And earlier we tried to do one component that was actually differentiated by a Boolean property, which determined whether we were logged in or not. So what we decided to do next is to say, okay, well, let's not do that. Let's not use that Boolean prop, and instead let's make a logged in navigation and a logged out navigation components. And then you say, well, I know, but they both have logos and they both have lists of links, and I don't want to have to repeat myself, right? So I'm going to just do this. I'm going to make a logged out navigation component. It's going to take some properties, nav links and action links. Then I'm going to display a logo, reusable set of navigation for those nav links, and a reusable set of navigation for the action links. So again, what do you guys think about this? You might say, well, I would write that. And honestly, so would I. But what are some of the issues that could happen here? Well, first of all, understand that we don't actually know how reusable nav actually renders, right? It's kind of a specific, it acts as though it's reusable, but it's very specific to these navigation bars. It's not intuitively understandable what that's going to look like when it's rendered. So even when we look at this logged out navigation component, we would still need to go to those files to see how they render, to understand what this component's going to look like. But second of all, realize that what if we wanted to change the way that the links worked? What if some of our links wanted to have icons, and maybe some of our links wanted to be represented any number of other ways? What would we have to do? Well, first of all, we might have to update the nav links property to include some additional information about the logos to show, or the type of link to show, or anything along those lines. Then we would have to update the reusable nav component to actually support and understand that new JSON structure, that new property. And then we would have to go to all the places that use reusable nav and make sure that they have now not broken now that we've updated it. So this might not be quite as easy as we thought it was going to be, and it might not be saving us as much time as we thought it was going to be. So how could we get around this? Well, let's just be specific. Let's say exactly what's in this logged out navigation. It's a logo, it's a set of links, which are reusable components. Then if we want to have a link that has an icon, we just add an icon to our link. In this way, we're being extremely specific of what we're doing. Now, do our two navigations look very similar? Yes. Do they share some copy-pasted code? Yes. But here what we're doing is we're saying that these things are more incidentally the same than exactly the same. And so we're choosing to emphasize that specificity as a way to make these things a lot more flexible to maintain, and waiting until they prove their reuse before we actually abstract them further. So the next strategy is to prefer components that isolate concerns. Now, concerns are like independent functions that deliver value to our users, which is not a great definition, but I needed something for the slide. And we isolate these concerns by containing them in components that deal only with that concern, right? So each concern is dealt with in only one place, and hopefully every place only deals with one concern. That's a perfect world when we're dealing with these components. What happens when you do that? Well, when you do that, your components are going to get smaller. The other thing is that your components are going to be a lot easier to understand, because you don't actually have to open other components to understand it, because it is only concerned with one thing, and it's the only thing that's concerned with that thing. So you don't have to look anywhere else. All of the world related to that concern is right in front of you. The last benefit of this is that components are more cohesive and concise, and they're less coupled to one another for much the reasons that I just said. They're focused on one thing, and they're not related to one another. So the best example of this I can think of is Downshift library from PayPal, right? It lets you make an autocomplete box, an element that does not easily exist in HTML yet. And there are some really complicated things to do with autocomplete boxes. The behavior can be really tricky, especially if you're going to reach to the back end for live matches. Accessibility can be really difficult. So having this behave well for people that have disabilities or are not sighted or anything like that, but work the same for other users. Input control can be really hard when you start talking about keyboards and mice and touch inputs as well. And of course, you have to know how to render and style the component. There's a lot of different ways to display an autocomplete box. So the Downshift library is really cool because it isolates the concerns by taking away all of the behavior, accessibility, and input control and dealing with that itself, and then letting us focus solely on the styling. So here we can see the example of Downshift what it's doing is again, it's a black box. We don't necessarily see how it's implemented, but it's going to give us here, at least in this version, I'm not sure if they've updated it more recently to use hooks, but in the version that I captured, they're using render props. And they give you a set of render props that you can then hook into the structure of the HTML and the styling that you're going to make. And as long as you connect these things appropriately, then you get to choose entirely how your thing is represented, and Downshift handles all of that behavior, accessibility, and input control. So those are the props that it gives us. And then we get to build our autocomplete box like this. And we get to choose the labels and the inputs, whether we're using ULs and LIs or any other type of representation, how we style them and lay them out. And we just connect those pieces from the Downshift library, and then it handles all of the rest for us. So we don't have to worry about how to implement an autocomplete box. They don't have to worry about giving us all sorts of styling properties and theming and ways to override their default styles. It makes their library easier to maintain. It makes it more useful and reusable for us, and it makes our code easier to write. This is exactly what it means to isolate concerns. The last strategy is the one that's perhaps one of the toughest to grasp, but it can be really powerful when you notice it. And it's to prefer components that bound complexities or on opposite sides of complexity boundaries. The key here is to understand that components don't have to know everything in the world to provide value. The best example of this are input boxes, right? So when you put an input box inside of your application, it doesn't need to know whether it's holding an address or a password or a bank account, right? It just has to be an input box. And it's up to the parent to know the context of what that input box represents in the context of your application. The parent gives that context to the child. The child doesn't need it to operate. When you do this properly, it can really simplify the design, the implementation, and the testing of your applications. And it can really make the child components easier to reason about. So I really struggled to find a really good example of this. So I just sort of made one which can kind of illustrate the point. So here we have a component that's a color status indicator. It takes a value and a low and a high threshold. But what it doesn't do is it doesn't say what that value is or what those thresholds represent, right? But it's going to say that I can take these values and I can put out some sort of colored indicator, using my proprietary method here. It doesn't know whether it's being used in some sort of financial spreadsheet program or something like that to indicate whether you have money in your account, or whether it's being used as the temperature gauge of a nuclear power plant, right? That's the best part. It doesn't have to know. This component is a lot easier to understand without the knowledge of where it's going to be used. Similarly, hopefully, the component that uses this is also easier to know and understand because it doesn't have to understand how to determine what indicator to show relative to those values and those thresholds. Now, where this really comes in more often is in Redux. And what I would say is that people, when they use Redux or any other similar state management library, will often connect far too many components to the global store because the framework and the libraries make it so easy to do. And what I would say is that you want to actually minimize the amount of components which are aware of the global store or anything global related to that, because whenever something is connected to the global store, it has automatically far more context about what's going on than it otherwise needs to. So I would say in your applications, if you're using Redux or something similar, to pull the data out of the store as early as possible and then pass it in traditional ways down to the child components. You'll find that this tends to make you write less quote unquote intelligent components and far smaller components, and overall make your system a lot easier to maintain. So in conclusion, again, there's no definitive way to know that you did things right. These are strategies, and you might decide to follow all of them or follow none of them, or to violate them sometimes or violate them never. So as your team is learning this, and as you continue to learn this, or really on any team, make this a group exercise. Sit down with new requirements and say, how do we want to represent this requirement as a set of components? What would be good places to make these cuts? This would follow then that you should make time in your process to produce software designs. Even if you're not going to do it as a group, at least give yourself an opportunity to say, well, this is what I want to do, and show it to others and have them give feedback upfront and early on when it's easy to make changes relative to later, say in the code review, or God forbid in testing, when you realize that something just will not work and you have to make really large architectural changes really late in the game under time crunch. Then whenever you have time, sit down as a team and look back on the things that you've built and say, how were they good? What things worked for us? What things didn't work? What gave us problems? What bugs have we been seeing? What's difficult to change? What's easy to change? How would we do things differently? And why would we do them that way differently? Really use the advantages of the experience you're gaining on your jobs to help build additional wisdom and to really level each other up, right? If you don't take that time to really think back on what you've done, you're not going to be growing as quickly as you can be. And just as an overall like Hallmark card greeting way of saying this, when in doubt, prefer duplication over abstraction. So don't be afraid of your copy paste button, and prefer composition over inheritance. Lastly, if you just want to see those strategies again, prefer components which are routable, components which are reusable or composable, components which are specific, components which are concern isolating, and components which bound complexity. All right, that's it. Thank you, everybody, for this opportunity. And like I said, if you have any questions, I'm not sure where we are on time, but if we don't have time to answer them here, we can hit me up on Twitter and we can talk about it there.
Yeah, we still have time, a few minutes for any questions. If anyone has some questions, just bring them up on the chat, and Rob will answer them for you.
I saw one question about being different advice to connect down the tree as much as possible to avoid unnecessary reconciliation. This is actually true. So there's the counter operating advice, which is to say that you want to subscribe to the Redux store as far down in the tree as possible, but as far up in the tree as possible as well, right? So it's this idea of balancing what is the correct component that is going to be responsible for that piece of data, responsible for its fetching, responsible for its update. This is, again, sort of the traditional unidirectional data flow concepts that are kind of at the heart of both Redux and React. So you're right. I'm not saying pull things out of the Redux store at like your app component and then push it all down, but neither pull data from the Redux store every single place where that data is needed. Instead, maybe do it one level higher or maybe 2 levels higher than you're doing it now, because those components will get simpler when you do that. But balance it against the renders. OK.
Cool. So thank you so much, Rob. That was awesome. Now we're going to give the place for our next speaker, Rishi.
Can you hear me?
Yes, I can hear you now. Just present your screen.
Just a second. Right, you can see my screen?
Yes, perfect.
Right.
Can you speak a little louder? It's kind of low.
Is that fine?
I think that's good.
Okay, is that fine now?
Yes, that's perfect.
Right. So, hey, hope you're having a great time. Thanks for such a great talk, Rob. My talk is going to be about, it's going to be a short talk about building offline first React apps with RxDB and Hasura. It is going to be a very philosophical discussion about the architecture, so I won't be really going into the code subtleties of things. So, firstly, I am Rishichandra. I work in the engineering team at Hasura, and I work mainly in React and Node.js. And since Hasura is a GraphQL centered company, all of us do a lot of GraphQL as well. If you want to know more about me and my social handles and my messed up opinions, you can just go to my personal homepage, and you'll find all of those things there. So at Hasura recently, we've been looking at a lot of different kinds of applications and different kinds of architectures, patterns, and paradigms of building applications. And recently, we built a lot of apps using the offline first architecture. And that's what I'll be sharing with you all today. So building offline first apps with RxDB and Hasura. Firstly, there are a lot of new terms here: offline first, RxDB, Hasura. So I'll quickly go through those just in case anybody hasn't heard about them. So what is an offline first app? In an offline-first app, the user-facing functionalities of the application do not worry much about the internet connection, which means that that the core functionality of the application stays consistent irrespective of the fact whether the user is connected to the internet or not. If you look at the high-level architecture, it is an app talking to the offline database and only the offline database, and then there is a sync process going on in the background, which keeps the offline database in sync with the database in the cloud. RxDB is a NoSQL database for JavaScript applications. It is also a reactive database, which means you can subscribe to the changes in the database. Subscribing to the changes in the database is important because we live in 2020 and everybody wants real-time features in the applications. We'll come to more about RxDB in a bit. Nextly, Hasura. Hasura is an open source engine, also called the GraphQL engine, that connects a lot of microservices, different GraphQL servers, APIs, and your database, and connects it into a single unified graph that your client can query. So Hasura does a lot of things, but for the scope of this talk, we'll worry only about the CRUD with the database. So Hasura natively supports Postgres, which means that if you connect Hasura to a Postgres database, you can instantly start querying the data in the database over real-time GraphQL. How it works is, say if there is a table called profile in Postgres, Hasura exposes a GraphQL root field called profile in the GraphQL schema, and when the client makes GraphQL queries, Hasura compiles it to a performant SQL query and returns the response. So having introduced the tech, let's look at the architecture again with our current stack. So we have a React application which talks only to the offline database, which in our case is RxDB, and the cloud database is Postgres. And the syncing between two happens over GraphQL, which is done through Hasura. As I said before, the syncing is done through GraphQL, and the syncing is easy because RxDB comes with an inbuilt replication plugin for GraphQL. So we can sync data between RxDB and Postgres because Hasura allows GraphQL CRUD over Postgres. So let's look at an example. We'll look at this architecture with an example of a Trello clone. This is the Trello clone that we'll look at. It's not the neatest of UIs, but it works. Everything works. I am also adding a to-do to clean up the UI. So you can add new tasks. You can reorder them. You can move them across columns and reorder them and delete them. So that is all the basic CRUD that we're taking care of. So what would the schema look for this Trello application? This is a very important question because, as we all know, Postgres is an SQL database and RxDB is a NoSQL database. So how would we model our data? Would our data be normalized, denormalized? So we have to think about all these problems while modeling our data, because the data is going to go into both SQL and NoSQL database. What we came up with for this particular app is this. On the right, we have the Postgres schema. We have three tables, that is task, user, and column. Task has ID, user ID, column ID, title, created at, column rank, updated at. User ID and column ID refer to user and column tables respectively. And column rank is useful for ordering the tasks across different columns. And on the left, we have the RxDB schema. As you see, we have only modeled the task table in RxDB. This is because user and column tables don't contribute to the core functionality of the application. Since we are building a Trello clone, the core functionality of the application is managing the task, moving them around, updating them, deleting them, and so on. So it will be pretty much enough to model the task table in RxDB. And as you see, there is a one-to-one mapping, so the sync will be very efficient. So having said the schema, let's go about how to go about building the database, building the application. Firstly, the most important thing is that all the assets of the app should be available offline because it is an offline app. The JavaScript and CSS and the asset and the images, everything should be available offline. Nextly, we start with building a client-only database, a client-only application that connects to RxDB. This is important because since this is going to be an offline first application, the app should work seamlessly without any authentication and any cloud database. So we'll first build an application that connects only to RxDB, and it works completely. Nextly, we'll add auth for managing the identities of the users, and finally, we'll set up sync between RxDB and Postgres. Since we have to, since the client is going to sync the data between RxDB and Postgres, we have to make sure that Postgres is secure. So Postgres has to be secure because we don't want malicious users to corrupt the database, right? So there are some basic rules that we want to enforce. Firstly, unauthorized users should not be allowed to touch the database. Just go away. And nextly, users should not be able to forge their identity. Like they should not be able to perform actions as somebody else. And finally, users must not be allowed to perform unwanted CRUD. Like, for example, a user should not be allowed to update the created at field of a task. Otherwise, the app just loses a sense of truth, right? So since we are connecting to Postgres through Hasura, Hasura comes with an access control layer. I'll quickly explain how the access control layer of Hasura looks like. Firstly, the authorization service issues a JWT to the application when the authentication happens, and this JWT is encoded with certain session variables like x Hasura star, like x Hasura role, x Hasura user ID. So this the application makes all the queries to Hasura with this JWT, and Hasura decodes this JWT to find out these session variables. Now, using these session variables, we can have granular access control rules at the table level. For example, in this case, if we have a profile table, we can have a rule such that if users have a particular x Hasura user ID, they should be allowed to access rows of only when the user ID is equal to that x Hasura user ID. So you can set up all kind of complicated rules as function of the session variables and enforce these conditions. So back to building our application. Firstly, we have to make the assets available offline. The easiest way is to use service workers. Service workers are one of the most efficient ways to persist the assets offline. Also, if you're using Create React app, it comes with a nice service worker configuration. So all you have to do is add this to your index.js, and your assets will be persisted. Your assets will be persisted offline. Nextly, let's see how to subscribe to RxDB from React. So the core philosophy of React, as we all know, is a component is a function of state and props, and it is subscribed to the state and props. Whenever there is a mutation in state and props, the re-render is triggered and the UI updates, right? So since the state of this application is RxDB, we want to subscribe to RxDB so that whenever there is a change in RxDB, our UI updates accordingly, right? To do this, we initialize a state variable called tasks, and when the database is initialized, we subscribe to RxDB. To do that, we just subscribe to a query of non-deleted tasks. And whenever there is a change, we update the state variable tasks with the latest results from that query, and then we pass around this task variable to render the UI. The CRUD is pretty straightforward. You can just look it up in the docs. I've just put up some snippets from my code base. This is insert, update, delete. This is a soft delete. I just set is deleted to true so that the task gets removed softly, but it still exists in the database. Another thing is there are certain important states to maintain. So when you'll go about building an offline first application, these three states are something you'll deal with all the time. Like most of the conditional flow of your application will be a function of these three states. Firstly, is logged in, whether the user is currently logged in or not. Secondly, the authorization headers, what the current authorization headers of the current session are. And lastly is online, which says that is the user connected to the internet at the current moment. So you can initialize these variables somewhere around you can initialize the state somewhere around the root of your application, and then pass them around however you want, React context, Redux, or just pass them around using props. So let's look at the flow of the application. Firstly, the app mounts. Once the app mounts, you check if the user is online. If the user is online, you check if the user is logged in. If the user is not logged in, you just clear the contents of the local database and show a login screen. If the user is logged in, you render the app using the RxDB data and start the sync between Postgres and RxDB. So far, so good. Now, if the user goes offline, nothing changes. Everything continues to work. We render the app using the RxDB data. All the mutations happens to RxDB. And when the user comes back online, we check if the session is still valid. If the session is still valid, we again render the data and start the sync. Otherwise, we throw away the data, which we throw away the changes that happened in the offline mode and show a login screen. Taking a step back, when you mount the application and the user is offline at that point of time, we still want to have the core functionalities of the application usable. And then when the user comes back online, at that point of time, you check if the user is logged in and make the same decision. If the user is not logged in, throw away the changes. If the user is logged in, start the sync. So this is pretty much the basic flow for any offline first application. You can have more edge cases, like for example, if it is a first mount, you would want to do things a bit differently, or you might have better ways of figuring out whether the data is unauthorized or the data is corrupt. You can do all of that, but it would mostly be an extension of roughly this flow. So the next important part of the application is sync. How we sync the data between RxDB and Postgres. So as I said earlier, that RxDB comes in with a GraphQL replication plugin, which allows replication of RxDB data to any GraphQL data source. So it just exposes a method called sync GraphQL, which takes a bunch of parameters. There's a GraphQL endpoint, the authorization headers, the push query. The push query is the query to push the changes from the new changes from RxDB to the remote database, and pull query is to get the newer changes from the remote database. And finally, we have live interval. That is how often we want this sync to happen, right? Let's look at the pull query. This is like a huge query. It looks like a huge query. Let's see what this does in plain English. So in case of pull queries, what RxDB does is it looks at all the tasks that it has locally, and it looks at the newest task, and then it makes a query saying, give me all these fields of all the tasks in the remote database which are newer than the newest task that I have locally. If you look at the where clause, it says, give me these fields where of the tasks where updated as is greater than updated at of my newest local task, and also give me the changes of the newest task. So that is basically the pull query. So whenever this query is triggered, you get the latest changes from the remote database. This is the push query. Push query is an upsert mutation. So RxDB tries to insert it whenever there is a change in any task or a new task is added. RxDB tries to insert that task. If the insert happens successfully, well and good. If it doesn't, if it fails due to a primary key constraint, which means if the task already exists in the remote database, then simply update the columns with the new data. So this is an upsert mutation. Pull query was a simple GraphQL query, and push query is an upsert mutation. So in a lot of cases, we want to force pull and force push data. Ideally, if you look at the sync configuration, we give a certain sync interval, and sync keeps happening at every given interval. But certain times we want to force pull or force push data just so that our both the data sources have the latest changes, right? Ideally, we want to force pull when some changes happen in the remote database. So like if something has changed in the remote database, we immediately want to pull those changes. Fortunately, we can do that because Hasura provides real-time capabilities on Postgres. So we can just start a subscription saying task, subscribe to the task table and the ID and updated at columns. So whenever something changes in the task table, like we'll get an event from the remote database through Hasura. And whenever we get this event, we can force pull the data from the remote database. Similarly, with force push, whenever something happens locally, we want to immediately inform the remote database about it, given that we are online. Luckily, RxDB does that by default. If some change happens locally, RxDB immediately tries to sync it with the server. And it's done. Like these are like the very basic principles using which you can build any kind of an offline first application. We are still looking at a lot of different patterns and paradigms. You can get in touch with us if you have any more ideas and feedback about this architecture. And there are also some limitations. First is compaction. So RxDB tries to maintain 1,000 revisions of all the mutations of the documents. This becomes a problem beyond that. So compaction is definitely an issue. Next is conflict resolution. Say two updates happen at exactly the same time. So RxDB doesn't know which, neither RxDB nor Postgres know which ones which ones should be committed. So in that case, there has to be a strategy for conflict resolution as well. Next, there are sync errors. So since the application talks only to RxDB and only to RxDB, we don't know if there are errors between RxDB and Postgres, the sync between RxDB and Postgres. The user might never know, and the sync might keep failing without any information to the user, which is obviously bad, and the patterns have yet to be figured out for this. And lastly, for complex schemas, say for example, there are many relationships in Postgres. It is very hard to model in a NoSQL database like RxDB. So I have linked some references for more reading. Firstly, this blog post is, if you're really interested in offline first applications, just have a look at this blog post. This talk and all the apps that we built are inspired from this blog post. And there are some more articles for reading more about the offline first architecture. As I showed this Trello clone as an example in this talk, if you want to look at the source code for it, you can just go to this Git repo, clone it, run Hasura, apply the migrations, and you can have the app running. You can try it out and it'll work. Cool, thanks. That's it. If you have any questions, I'll answer them in the comments. That's it from my side. Bye.
Hey, thank you so much, Rishi. So if anyone has any, oh, hold on. Someone has a comment. Let me see. So he's just giving you the thanks. So if anyone has, there's also, that's actually a question right here. Application.
Oh, is it? Okay, I'm not an expert on RxJS. Thanks for that information. I'll look into it.
Cool. So if anyone has a comment, just put it on the on the comment section, and I will display it. If not, we're just going to terminate the meetup. And thank you so much, Rishi. That was very informative. I appreciate it. And thanks so much for everyone who attend to this meetup. See you guys next month for some awesome speakers as well. Take it easy.